When you're solving a system of equations using the elimination method, you're going to do exactly what it says. You're going to eliminate or cancel one of the sets of your variables. So let's take a look at this first problem. In this first problem, I can see that the negative 2y and the positive 2y are already set up to cancel or to eliminate. So let's take the equation and take those two. At face value, 7 plus 6 is 13x. The y's are going to eliminate is equal to 26. We're going to divide both sides by 13 and get that x is equal to 2. Once you get the first answer, you're going to take that answer and go plug it back into one of the original equations. So I'm going to go to that top equation. And so I'll say 7, but where the x is, I'm going to put the 2 that I just solved for. Minus 2y is equal to 12. So 14 minus 2y is equal to 12. Subtract 14 from both sides. So negative 2y is equal to negative 2. Divide by that negative 2, and y is equal to positive 1. Some teachers like your answers to be written as ordered pairs, so if that's the case, remember that every ordered pair is x and then y. So you're going to put your x answer first and your y answer second. Let's take a look at problem number 2. If you'd like, you may pause the video and try the problem on your own to see if you get it correct. So let's eliminate a variable. I'm going to eliminate those x's, so I have a positive 3 here. So I would need to multiply the bottom by a 3 so that I have a negative 3 and a positive 3 to cancel. So take the top equation and bring it over just like you see it. On the bottom equation, we're going to distribute that 3 to everyone. That gives us negative 3x plus 9y is equal to negative 15. The x's are going to cancel just like we wanted, and that gives me 5y is equal to negative 20. Divide by 5, and y is equal to negative 4. Just as in the previous example, once you get that first answer, you're going to go back to one of the original equations and plug that back in. So I'm going to go to the top equation. So I'm going to have 3x minus 4, but where that y is, I'm going to put the y value that I just found is equal to negative 5. So 3x, and then here a negative times a negative is a positive 16. Subtract your 16 from both sides. You get 3x equals negative 21. Divide by 3, and x is negative 7. And again, if you'd like to write that as an ordered pair, that's negative 7, negative 4, recalling that x comes before y. Okay, let's take a look at problem 3. Again, pause the video if you'd like to see if you can get it on your own. So here we're going to eliminate. I'm going to choose the y's because I have a positive and a negative. So let's do, and sometimes I'll call this the flip-flop method. In this top equation, you have a 2. So I'm going to take that 2 in the top equation and put it in the bottom equation. And in the bottom equation, I have a 3, and I'm going to put that in the top equation. Doing so ensures that I have 3 times 2 and 2 times 3, which will always be the same values to eliminate. I also already note I have my positive and my negative. So let's distribute through the top, and that gives me 21x plus 6y is equal to 33. In the bottom equation, that's going to be to distribute here. That's going to be 4x minus 6y is equal to negative 58. Those y's eliminate like we wanted them to. That gives me 25x is equal to negative 25. Divide by 25, and we get x equals negative 1. All right, let's take that -1 and let him go live in one of those houses up there. So you can put it in the top equation or in the bottom equation. I'm going to go to that top equation. So I'm going to have 7, but where the x is, I'm going to put the -1 that I just found, plus 2y is equal to 11. So solve that and you get -7 plus 2y is equal to 11. Add your 7. So 2y is equal to 18. Divide by 2 and y is equal to 9. So my ordered pair is -1, 9. Let's take a look at problem number 4. So let's choose a variable to eliminate. I'm going to eliminate the x's. So if this is a +4, I need for this to be a -4. I've already got my negative, so I just need to multiply by 2, so that 2 times -2 would be a -4 to cancel out that +4. So bring your top equation over just as is. The bottom equation, I'm going to multiply by -2 to every 1. So that's -4x plus 10y is equal to -18. So my x's do eliminate, but my y's are also going to eliminate. So I have nothing left, 0. On the other side, it just so happens that the 18 and the -18 also cancel and eliminate. So I'm left with 0 equals 0. That is a true statement. When you get a true statement in a systems of equations, that means that you have infinitely many solutions. Infinitely many solutions. Be really careful not to say that the answer is true. I know that that can be easy to do because y'all take a lot of true and false tests. The answer is infinitely many solutions because you got a true statement. Let's take a look at problem number 5. And once again, if you would like to pause the video and try it on your own and then come back and check. So let's eliminate a variable. I'm going to eliminate the x's. So I'm going to do that flip-flop method again. So if I have a 3 in the top, I'll put a 3 in the bottom equation. And if I have a 5 in the bottom equation, I'll put a 5 in the top equation. That way I can guarantee that 5 times 3 and 3 times 5 will be the same value. In this case, 15 and a 15. But they're not going to eliminate unless one's a positive and one's a negative. So let's put a negative sign on that top one. Okay, let's distribute that negative through, and that's going to be -15x plus 10y is equal to 40. The bottom equation, I'm going to take the 3 through to all of those people. That's going to give me +15x minus 12y is equal to -30. The 15 and -15 are going to eliminate. The y's, that'll be -2y is equal to 10. Divide by -2, and my y is -5. Now let's take that -5 and go plug it into one of those y places right there. I'm going to go to the top one. So if I do that, I'm going to have 3x minus 2, but where the y is, I'll have -5 equals -8. So I have 3x plus 10 is equal to -8. Subtract that 10 from both sides. So I have 3x equals -18. Divide by 3, and x is equal to -6. Giving me the ordered pair -6, -5. I do want to talk about the fact that you can check your answers, which is really great if you're taking a quiz or a test. Here's what you do. You take the answers that you got for x and y, and you put both of them back into each equation to see if you get what you're supposed to get. What I mean is this. I have 3 times my x, which is -6, minus 2 times negative 5, hit equals, and sure enough, that's negative 8. We got to try it in the bottom equation too. So 5 times your negative 6 minus 4 times your y, which is negative 5, equals, and sure enough, that equals negative 10. It must check in both equations to be a valid solution. Let's take a look at problem number 6. So we have to pick a variable to eliminate. I'm going to eliminate the x's. I do notice that I already have a negative and a positive, so all I have to do is multiply by 2 because that's going to give me 2 times 8 to eliminate with that negative 8. So distribute your 2 through that equation. That gives me 8x minus 6y is equal to 16. The bottom equation, just bring that over just like it is. So those x's do eliminate, but the y's also eliminated. So again, I have nothing left, 0. Equals, on this other side though, the 16s don't cancel here because they're both positive. So instead, they add to get me 32. Well, 0 does not equal 32. That is a false statement. When you get a false statement in systems of equations, that means there is no solution. There is no solution that is true for both of those equations. Again, the answer is not false. The answer is no solution because you got a false statement. All right, let's take a look at problem number 7. And again, if you'd like to pause the video and try it on your own. So let's choose a variable to eliminate. Possibly you might choose your y's. If you do that, you'll do a negative 6 to knock out that positive 6 in the denominator. I think though I'll do the x's. So if that's a negative 4, I need for this to be a positive 4, which it will if I multiply by 2. So that top equation becomes 4x plus 2y equals negative 2. The bottom equation, just bring that on over, and you have negative 4x plus 6y is equal to 6. So the x's eliminate, just like we wanted. That gives me 8y is equal to 4. So I want to solve for y, and our natural tendency might be to say, oh, 4 goes into 8 2 times and get 2 for the answer. But be careful because remember, when you're solving for a variable, you want the variable by itself, so we're going to need to divide by the 8, not the 4. So then that's going to leave me with 4 over 8, which is a fraction that reduces to 1/2. Now, just like before, let's take that fraction and let's go put that into one of his houses up here. I've got this one and I have this one. I'm going to be strategic about this and I'm going to plug it into the bottom equation because I think it's going to be a little bit nicer there. So that will be negative 4x plus 6, but where that y is, I'm going to put that 1/2. So I have negative 4x, and here really all you're doing is saying I want half of what 6 is, which is 3. And that's equal to 6. Subtract your 3 from both sides, and you get negative 4x is equal to 3. Divide by negative 4, and x equals negative 3/4. So my answer is negative 3/4 positive 1/2. Let's take a look at problem number 8. And again, if you'd like to pause the video to do this on your own and see how you do. All right, let's eliminate. I'm going to eliminate the x's. So I'm going to do the flip-flop method again. If I have a 5 in the top equation, I'll put that in the bottom equation. If I have a 2 in the bottom equation, I'll put that in the top equation. I have just guaranteed that 2 times 5 is the same thing as 5 times 2. They're both 10 and they'll eliminate as long as one of them is a negative. So I'm going to put a negative onto the top equation. That's going to give me negative 10x minus 8y is equal to positive 36. In the bottom equation, I'm going to multiply that 5. That's going to give me positive 10x plus 15y is equal to negative 120. Those x's are going to eliminate, and I get 7y is equal to negative 84. Divide by 7, and y is equal to negative 12. All right, let's let that 12 go live in one of his houses there, so I can plug it in here or into the bottom equation. And so I'm going to go to the bottom equation and plug that in. So I'll have 2x plus 3, and where my y is, that's negative 12, equals negative 24. So 2x minus 36 is equal to negative 24. Add your 36. You have 2x equals 12, and so dividing by 2, x equals 6. So my ordered pair is 6, negative 12. Again, remembering that x always comes before y in an ordered pair. Okay, let's take a look at problem number 9. Again, pause this video and try it on your own to see how you do. You can choose to eliminate your x's or your y's. I'm going to eliminate my x's. So if that's a 4 in the bottom equation, I'm going to need a negative 4 in the top equation. So distribute that through. And I have negative 4x minus 4y is equal to negative 8. The bottom equation, I'm just going to leave that just like it is. And so those x's are going to eliminate. And I'm going to have y equals 8. Take your y equals 8 and let's go plug it into either one of those equations. I'm going to go up to the top one to plug that back in. So negative x minus y, which is 8, equals negative 2. Add your 8 to both sides, and so I'm going to have negative x is equal to 6. Divide by negative 1, and x equals negative 6. My ordered pair is negative 6, 8. Last one. Again, pause that video and try it on your own to see how you do. All right, so we're going to eliminate a variable. Because I already have a positive and a negative on those y's, I think those are the ones I'm going to choose. So I'm going to flip-flop. If I have a 5 in the top equation, I'll put a 5 in the bottom equation. If I have a 4 in the bottom equation, I'll put that in the top equation. All right, let's distribute through, and that gives me 28x plus 20y is equal to negative 48. I'll distribute that 5 to all the people there, and that gives me 15x minus 20y is equal to 5. All right, those y's eliminated just like I wanted them to. So here I have 28 plus 15, which is 43x equals negative 43. Divide by 43, and x is negative 1. Then I'm going to take this equation, this negative 1, I'm going to go put him back into one of his houses. So I have a negative 1 to put in either one of those places. I'm going to put that in the bottom equation. So 3, but where that x is, I'm going to put a negative 1 minus 4y is equal to 1. So negative 3 minus 4y is equal to 1. Add your 3. And you have negative 4y is equal to 4. Divide by that negative 4, and you have negative 1. So my answer is negative 1, negative 1. If this video is helpful, please like and subscribe to my channel. Feel free to leave a comment as well, and maybe even share the video with a friend. All of these things will allow me to continue to grow my channel so that I can help build your math esteem one problem at a time. See you later.